This video will demonstrate how to insert data into an array. It will be a fairly simple process using a loop and an array. So we'll go ahead and take a look at what is going to happen when we try that. We start out by saying we have an int main. We're into a program but not very far. We have no data stored or requested at this point, so we haven't declared the array, and we'll do that now. Once we declare the array, we have some number, and the max charge in array, remember, is the capacity of the array, not necessarily how much we'll be using, but it's how many characters in this case that are available can be stored in the array. If we continue on with that, and we go ahead and store the word restaurant into that array, then we can see here that we're going to be we have all the letters in from element 0 up to element 8. So this is 9 characters at this point. But we might also notice that in fact it is misspelled. So we're going to have to correct that, and it means we're going to have to insert a letter into the array. And the key point here is this is without losing the existing data. And what that means is I've got to put a U right in there, but I've got to move everything else over, because if I just simply drop a U in there, then I lose the R, and we're still misspelled. So what we need to do is we need to move everything over, and then we can drop the U into there. We will do that with a fairly simple loop. We will start with a counter that is also in fact the size of the array. It is how many letters are in the array. And we'll have an insert at, which is, if we recall here, the insert at is the element at which we want to place the U. So we'll have that. We're going to loop till we get to that point. Once we get to that point, then we will in fact stick our U into that slot. So we'll go ahead and get started up. We're going to put the screen into this format here, and we'll be losing the text pretty soon, but we'll have a format that we can kind of watch our process of conducting this activity. So we'll go ahead, and the table will hold the variables. We have the counter at 9 right now. We have the insert at 5, and these were declared in the previous screen there. But we're going to set it over here because we're going to keep track of this. And by the way, this is a very good way to do your own analysis of operations with arrays, or sometimes any kind of code operations. Simply make yourself a table of the variables that are involved, and then in the case of arrays, go ahead and make draw out the array itself with the indices, and you'll be able to track what's going on. This is how to analyze and prove that you are doing what you meant to do into the array. So one more step, and as I said, we're taking the text out of this, so we've got a fairly clear screen and we can watch what's going to happen. So here we're ready to go, and we'll go ahead and take our first step. Going into this, we're going to test if the counter is greater than insert at. We can look over here and see that in fact it is, so we're okay to make a move ahead there. We'll go ahead and we're going to assign from the character array at counter -1. Now the counter is 9, so this array, character array element at index 8, we're going to take that letter right there, and we're going to assign it to the character array at 9, which is the counter itself. So let's back up. We're going to take it from counter -1, which is essentially 1 down. Counter -1 is going to be taken from this element, and it is going to be assigned into the element at counter, index 9, and we can see that right now it has an R in it, but once the assignment operation happens, now we have copied what is at counter -1 into what is now at counter. Not a terribly difficult or complicated process so far, but we'll go ahead and pursue it a little farther. So our next step here is to update the counter. The counter is presently at 9, so we decrement it. Now the counter is at 8, and we can go ahead and take our next step. The loop is going to come back up and retest. So we now test, is the counter greater than insert at? It is, so that means the loop can continue. Now we're going to the counters at 8. Counter -1 is at 7. We've got a letter N right there. We're going to take that and we're going to assign it to the array element at counter, which is index 8. So we're going to take this n right here from counter minus 1, and we're going to assign it up to here and overwrite this t with an n. So that is our assignment operation. We'll take our next step here. The counter is presently at 8. We will go ahead and decrement it to 7, and then we will continue our loop. We come back to the top here. Counter is in fact greater than insert at, so we can continue this process. We will drop down here. Now counter minus 1 is counter at index 6, the element that has the A in it. We're going to assign that to the character array element at counter, which is at 7. Right now it has an n in it, but when we copy this counter minus 1 from this location here, then we will have an A in it now. So that's the process of assignment there. We've moved this up. There is no wholesale movement here. Everything we do with arrays, we have to do one step at a time, and in this case, one element at a time. So we'll go ahead and take our next step here. The counter we know is presently at 7. We decrement it. It is now at 6. And we can go ahead and give a try back to our loop again. The counter is 6. The insert at is 5. So we are still greater than, and this is true. So we'll come down here. We're going to reach down from counter 6 down to minus 1. So we're going to look at the index 5. The element at index 5 is R. We're going to assign that to the char array element at counter, which is 6. That has an A in it, but we're assigning it from the one below it. So in fact what that will become is the R that was right down below. We'll take our next step. The counter we know is at 6. We'll decrement that guy, and he's now at 5. We'll come back to the top and we ask the question, is counter 5 greater than insert at 5? And the answer is no. This is going to resolve to false. So when we get here, we're going to find out that the loop is not going to be able to continue on any further. So what will happen then is it will fall through to this next step right here. Now we are at insert at, which we know is element or index at 5. The element right here presently has the R in it, but when we implement this action right here, we place a U in there, and we have now overwritten the R that was there. If you can see this, we've overwritten everything. We took the T and moved it to here, we took the N and moved it to here, the A and moved it from here, the R and moved it from there, and then we were to overwrite that R with the U. And remember, when I say the word move, we really don't. We actually copy from one to the next. There is no real move operation because there's always something in here. You can blank it out or you can put something else in it, but until you write something into it, it stays the same as it was. So one by one we copied these up, moving them out of our way so that we could in fact stick our U in here. Now I want to point something else out now. If you'll note, given the way this loop works, counter was going to come down to 5, and in fact you are assured that counter will be 5 when this loop completes. That is a very handy thing to know in any loop situation. What will the loop control variable or whatever you're doing, whatever variables are changing, what will they be when the loop ends? And in this particular case, the counter will be the same as insert at value, which is 5. So it is actually possible that you could have put counter in here, and that would have been perfectly legitimate and will work just fine, thanks to the fact that you've conducted an analysis of what counter will be when this loop quits, and what counter not just will be, must be. Counter must be 5 to get out of this loop. So we have satisfied our circumstance here. We have a better spelled word now, and maybe now's the time to go home and catch some dinner. But in any event, we can go ahead and wrap up this video here. This is our inserting data into an array, and that is different than appending. We will take a very brief video on appending, but this is just a quick array or a quick video to show us how to insert data into an array. We have to move the data out of the way one way or the other, or we will lose it. And in some cases it's okay to overwrite some data, but in this case it would have lost us. We would have stayed misspelled no matter what we overwrote. So we had to move everything up and out of the way to do that. You'll notice also that we had to start at the top and we had to increment down to make that happen. This cannot be done from the bottom up without some seriously ugly gyrations. Alright, so we'll go ahead and finish up this video about inserting data into an array.